Today, we are solving LeetCode 118 Pascal's triangle. This is an easy problem, but it teaches some very important DSA concepts. In this problem, we will learn 5 key concepts. First, how to build a 2D list row by row. Second, how previous results can help us build the next result. Third, how to handle boundary elements carefully. Fourth, how nested loops work in pattern-based problems. And fifth, how Pascal's triangle is a simple example of dynamic programming thinking. Let us understand the problem first. We are given an integer num rows. Let me switch the screen. We are given an integer num rows. We have to return the first num rows of Pascal's triangle. For example, if num rows is 5, then the answer should be 1. Answer should be 1, 1, comma 1, 1, comma 2, comma 1, 1, comma 3, comma 3, comma 1, 1, comma 4, comma 6, comma 4, comma 1. And if num rows is 1, then answer is just 1. So we have to return a list of arrays. Now, what is a Pascal's triangle? Pascal's triangle is a triangle where every row starts with 1 and ends with 1. Every middle element is found by adding 2 elements from the previous row, like you can see in this animation. The formula is current row at index j equals previous row at index j minus 1 plus previous row at index j. So this is the formula. Let me switch it to the pen paper view. I hope the screen is visible. So the formula is extremely simple. First of all, what is the Pascal's triangle? Let's start if of row 1. So what is our nums? Our num rows is 5, for example. Num rows is equal to 5. Then this will be the Pascal triangle. Row 1, there will be only 1 1. Row 2, 2 ones will be there. Row 3, 3 numbers has to be there. So 1 and last is 1. And in middle, it will be 1 plus 1, that is 2. Okay, now row equal to next row will be like this. It will be 1 and last will be 1. This number will be 3 and this number will be 3. After this will be the fifth row. Then ends will be 1. This will be 1 plus 3 4, 3 plus 3 6, and 3 plus 1 4. So this will be our complete Pascal's triangle. Now let's say our num rows is equal to, let me zoom out. Now let's say our num rows is equal to 3. Then the triangle will become 1, 1, 1, 1, 2 and 1. So this is row, first row, second row, and third row. And if our num rows is equal to, let's say, 7, then our triangle will be like this: 1, then 1, 1, then 1, 1, and here 2, then 1, 3, 3, and 1, then 1, 4, 6, 4, and 1, then will come 1, 5, 10, 10, 5, then 1. Finally, so 1, 2, 3, 4, 5, 6, 1, 6, 15, 20, 15, 6, and 1. So this will be our Pascal triangle of num rows equal to 7. So what is the formula that we are using to compute the next row? Let's say Pascal, so row k equals, or let's say row I equals, and row I, and let's say our Pascal triangle. Uh, so Pascal triangle is a 2D matrix. So it will have first element as 1, second element as, second row as 1, 1, third row as 1, 2, 1. Then next row will be 1, 3, 3, 1. Then 1, 4, 6, 4, 1. Then will be 1, 5, 10, 10, 5, 1. Then will be 1, 6, 15, 20, 15, 6, and 1. So this will be our, this is what? This is a 2D matrix, 2D array. So what is our formula to compute each element of this 2D array? We say that, for example, if we have computed till nth row, let's say we want to Pascal triangle row I and column j. So that is equal to Pascal triangle row I minus 1 and column, for example, consider 2. So to compute 2, this I equal to 0, 1, 2 and j equal to 1. So what we need is Pascal triangle I1 and 0 plus Pascal triangle I1 and 1. So we want I minus 1 and j minus 1 plus Pascal triangle I minus 1 and j. So that is a simple formula to compute. And for the boundary elements, we always have 1. So by example, it is very easy to get. Now let's switch to the code. But can we do it in a shorter way? So the answer is yes. Pascal's triangles values are related to combinations like NCR. But for beginners, that is not the best approach here. The problem itself gives us a natural pattern. Each row depends on the previous row. So we can build the triangle step by step. So let us define an answer list. Initially, answer is empty. Then we create rows one by one, and with the formula, we will get the next rows. For the boundary condition is important here because the first row has only one element. If we blindly add one at the start and one at the end, the first row will become 1 comma 1, which is wrong. First row has only one element. So we must be precise here. Now let us write the pseudocode. Pseudocode first create an empty list called answer. Then loop from I equal to 0 to nums rows minus 1. For each I, create a row and put 1 at the beginning of the row. Then for middle columns, loop from j from 1 to I minus 1. For every middle position, we compute our row. The formula that we discussed. After the middle elements are done, if it is greater than 0, append 1 at the end. Finally, append this row to answer, and then we return answer. So we could have directly written the Python code, but this will give you a rough idea. So we initial answer equal to an empty list. Then for I in range num rows, so it indicates that I will run from 0 to num rows minus 1, both inclusive. Row equals 1. Then we first row is initialized as 1. Uh, Actually, we initialize the row as a single element, 1. Now we'll run the loop for j in range 1 to I. We compute the value and then we append this value to the row. Then we check if I is greater than 0. Row dot append 1. See, the boundary condition is taken care of here. For I equal to 0, we will not append 1. Finally, we do answer dot append row and we return the answer. So let us dry run this code for num rows equal to 5. So let's dry run this code on pen and paper. Let me switch the screen. I hope it is visible now. Okay. So the example is this: num rows equals 5. So initially our answer will be equal to empty, and let's this I will be equal to 0. I will take these values 0 to number 0, 1, 2, 3 and 4, and our row will be equal to 1. Now j will become 1 to I. That means j will not be for 1 to 1 comma 0 for I equal to 0 when the pointer is on 0. Then j will not take any value. So we go to the next line, that is if I greater than 0. So I is not greater than 0. So we will finally answer dot append. Answer dot append will become this will become 1. Answer will become this. Now the value of I will change. The pointer will move to this value. Now row will again become the same as 1. Then we will go for j in range 1 to I. Now j will have 1 value. And then we'll check value equal to answer I minus 1 comma j minus 1. So 1 to 1, sorry. So j will again not have any value because range 1 to 1 is nothing. The thing is range 1 to 1 is empty. Nothing is there. So now the if I is greater than 0, I is greater than 0, so row will row dot append 1. So row will become this 1 comma 1, and answer will become this 1 and 1 comma 1. So answer will keep on appending. So now I will become 2. Row will again become 1. So the value of row will become 1 again. Then j will have range equals 1. When j is equal to 1, then what I will do, I will compute the value. So value will become answer I minus 1, j minus 1. I minus 1 is 1 and j minus 1 is 0. So it will be 1 and plus answer I minus 1 j. So that is again 1. 1 plus 1 equals 2. Then I will do row dot append 2. So row will become 1 comma 2 and I is greater than 0. So I will append 1 to the row. So it will become 1 comma 2 comma 1. Now answer dot append. So this will be appended to the answer. Let's do for next the I value of I will become 3. So row will now again will take this value new value 1. Then j will have new values will be 1 comma 2. Now we will compute value. So value equals answer I minus 1 comma j minus 1, that is 1 and plus 2. So it will become 3. Value will become 3. and row to append, we will append 3 to it. Then for j equal to 1, we will go j equal to 2. So again the value will become 3 and 3 will be appended. Then the j inner loop ends if I is greater than 0. That is true, I is equal to 3. So we will append 1 to the row. Done, and finally we append this row to the answer. So this will be appended. Now let's do for next I value. So this time j will be 1, 2, 3. Row will again become equal to 1. Now we will go to j equal to 1 and the value will become 4. This 4 will be appended to it. Then we go to j equal to 2. Then value will become 3 plus 3, that is equal to 6. Then we go to j equal to 3. The value will become, it became 6, now it will become 4. This will be appended. Now finally if I is greater than 0, then row dot append 1, and finally this is appended to the answer. 1, 4, 6, 4, 1. So this is the final answer. This will be returned. So this is how the complete code is dry run. So let me switch back to the coding screen. Let us now run this. Okay, it is test case is pass. Now before submitting, let's discuss its time complexity. So we can see that we need to compute each and every we need to go through each and every element of the Pascal triangle, and total number of elements in Pascal triangle is, if num row is 5, then we have 25 such elements. So it is num rows square, so order of n square, and the space is again same, order of n square. You see, because we are doing num square because num row square because it is of the if we have 3 num rows, then we can take it by an example. If we have 1 num rows equal to 1, total number of elements equals 1, num rows equals to total number of elements equals 3. Then for num rows equal to 3, it is 6. For 3, it is 6. Then again for 4, it is equal to 10. So what is this formula? So 1 plus 2, then 3 plus 3, 6 plus 4, then 10 plus 5. So next will be 15. Then will come 15 plus 6, that is 21. So the total number of elements is of this series 6 plus 4. So it is any 1 plus, let's say, num rows. So Tn in general is Tn equals first element, that is 1, plus num rows minus 1, so it is 5, it is 1 plus 2 plus 3 plus 4. So it is this 1 plus 2 plus 3 plus, will go till n minus n, and that is equal to n plus 1 by 2. So that's why it is of the order n square, and space is also of the order n square. It is nothing, very simple thing. If whatever is my num rows, my total number of elements will be uh, summing till that num rows. For example, my num rows is 3, then 1 plus 2 plus 3. If it is 4, then 1 plus 2 plus 3 plus 4. If it is 5, then 1 plus 2 plus 3 plus 4 plus 5. And sum of the natural numbers till n, that is equal to n plus 1 by 2. So it has the dominating term, that is equal to n square by 2 plus n by 2. So this square part is the dominating part. That's why the order is of the order n square. Very simple. I'm summarizing it once again. Time complexity is same as the number of elements in the Pascal triangle. And for a Pascal triangle of size num rows, or with rows as equal to num rows, it will have elements of the order of num rows square. That's why time complexity is of the order of num rows square. Now let's submit the code. Okay, so all the test cases are passed. Let's discuss some common mistakes. So first one is that adding 2 ones for the first row. The first row should be 1, not 1 comma 1. That is why we use if I greater than 0, row dot append 1. Mistake number 2 is confusing row index and column index. For middle values, we use answer I minus 1 and j minus 1 plus answer I minus 1 comma j. Here I minus 1 means previous row, j minus 1 means the left upper element, j means the right upper element. Mistake number 3 is running the inner loop incorrectly. The inner loop should be for j in range 1 to y. This means we only calculate middle elements. We do not calculate the first and last one. Mistake number 4 is trying to modify the previous row directly. Always create a new row and then append it to the answer. And mistake number 5 is thinking this problem needs a complex formula. So this is a mistake, it does not. The cleanest solution is to build the triangle row by row. So the main learning from this problem is whenever the current result depends on the previous result, think about building the answer step by step. This is the foundation of dynamic programming. And that is it. We have solved Pascal's triangle using a clean row by row approach in Python.